Hello. I hope you're enjoying your time away from class, but I just want to do a really short, quick video on 12.4 so that you would understand what your notes are talking about. And you do have an assignment on Cengage or WebAssign on this topic, so please make sure you do look at it. So similar polygons are polygons that are the same shape, and all of their angles are exactly the same. The only difference is they're really just scaled versions of each other. So one's a little bit smaller, a little bit bigger. Other than that, they are identical. So in this example right here, I have two quadrilaterals. The one on the left is a little bit smaller than the one on the right. Now the thing that you need to figure out with these scaled drawings is how much smaller or how much bigger the polygons are. These numbers are kind of nice if you look at them. 1 compared to 2, 5 compared to 10, 2 compared to 4, and 3 compared to 6. It's a little bit easier to see that everything in the bigger one is twice the size of the smaller one. So the scale factor could be 2 to 1 because everything is twice as big as the small one. You can also think of it as everything in the small one is half the size of the big one, and you can go either direction. Now we're going to use this to help us find missing information. So in this example 1, I have a couple pentagons here. It says AB is 12. So let's see if my writing marker is working. So that's 12. And then it says DE is 3. And those little slashes just mean the other shape. So the other AB is 8. And it's asking us to find the other DE. So we can tell the picture or the pentagon on the left is a little bit bigger because the 12 is bigger than the 8, which is in the same position. We want to figure out how much bigger it is. So what we do is take the two numbers that are in the same location and divide them. So we're going to take 12 and we're going to divide it by 8. 12 divided by 8 is 1.5. So the bigger one is 1.5 times the size of the smaller one. So if I was moving to the bigger one, I would multiply. Everything in the smaller would get multiplied to become the bigger. But now in our case, we know the bigger number of 3 and we're moving smaller. So when we're moving smaller, we actually divide the number. So if you're moving bigger, if you're moving bigger, you multiply, and if you're moving smaller, you divide. So we're going to take 3 and we're going to divide it by 1.5. 3 divided by 1.5 is 2. So the side that we're looking for, the new DE, or the other DE, is 2 units, whatever those units happen to be. So if we're going to the smaller shape, you divide. If we're going to the bigger shape, we multiply. Okay, let's look at example 2. We do really have two shapes here. The idea, though, is that one is literally sitting on top of the other one. If you have a hard time seeing that, what I would suggest is that you pull them apart. So A, D, E, and then A, B, and C. So let's see, they tell us AD is 20. They tell us AB is 24. So the way I have it drawn, the bigger one is on the right. BC is 18. And they're asking us to find DE and AE. So they're asking us to find information on the smaller triangle, not the bigger triangle. And one thing that should have been noted here, these are right triangles. There should have been a little tiny square here in the corner. Okay, so we have the 20 and the 24. So let's figure out how much bigger the bigger one is. So we're going to go bigger divided by smaller. 24 divided by 20 is 1.2. So it's not a lot bigger. It's 1.2 times bigger. Now we're going to the smaller To find x, we're going smaller, so we're actually going to do 18 divided by 1.2, because those are in the same location. 18 divided by 1.2 tells us that this DE is 15 units. Don't know exactly what they are, but it's 15 units. Now, y doesn't have a respective number over here. We don't know how big AC is, and we could find it and then figure it out. Or you may have noticed already that we have a right triangle, and all right triangles, if we know 2 out of 3 sides, we can use the Pythagorean theorem. So really the other way we could do this is say 20 squared plus 15 squared equals what I wrote as y squared. So 20 squared plus 15 squared oh my gosh, I did it 3 times now. I kept hitting multiply instead of add. So I have 625 equals y squared. So if we square root both sides, we end up with this is 25. So DE is 15 and AE is 25 units. So these are the answers we're looking for on example 2. Okay, bring any questions that you have back to class on Thursday, and we will talk about them, and I hope you enjoy your time away. Thank you.